Hey guys, and in this video I'll be going over the first set of 3 parts to this series on the PLL algorithms. Now as I just said, there will be 3 parts to this video, and this is going to be the first part. So basically what I'm going to be doing is I'll have the algorithm in the upper left hand side of the screen for each case, and I will demonstrate the algorithm at a regular speed, and then I will demonstrate it a bit slower, so you'll have a better understanding of how to use the cube and rotate it and such. Now, I want to say before I get started that I learned all of my algorithms from Crazy Bad Cuber's series on PLL algorithms, so make sure to go check out his video if you have any problems with mine. And I also want to say that the order of which I place the algorithms is somewhat similar to his. However, some of it is influenced from his tutorial, but most of it is just my own personal ideas of organizing the algorithms so that it would make sense to someone that's learning how to solve the cube using these algorithms. So let's go ahead and get started with our first set, the first 7 cases. Okay, so the first of the 7 algorithms we're going to go over today is called the T permutation, and this is what it looks like. So basically we have this edge and this edge need to be swapped, and this corner and this corner need to be swapped. So we're going to hold our cube so that the headlights are on the left side. And the easy way that I recognize this case is simply that we have 2 bars here that are solved the same color and on the back side, and that this color right here is the opposite of where it's supposed to go. So again, we hold the cube so that the headlights are to the left side, and here is the algorithm at the regular speed. And now a bit slower. Okay, so for the second algorithm here, we have what is known as the Y permutation. And the easy way to recognize this is that we have 2 solved bars on the left side and 2 solved pieces on the right side. So we have 2 bars here that are solved, and then we have 1 corner here that has each color on each face is the opposite of where it's supposed to be. So as we know, orange is opposite of red and blue is opposite of green. So that means that this corner piece is going to have to go back here. And the other way we can tell is that this edge needs to be swapped with this edge. So we hold the cube so that the only unsolved corner piece is on the right side here, and that we have 1 bar on this face and the other one to the right. So we go ahead and do this algorithm, and here it is at regular speed. And now a bit slower. Number 3. We have what is known as a JA permutation. Now there are 2 algorithms that go along with this case, JA and JB. We'll get to JB next. But for JA, we can tell that one face is entirely solved, which in this case it's blue. And we have bars as other solved pieces. So the way we can recognize this case is that we have all bars on the left side of each face. So for example, if we hold the cube so that the solved face is to the left of us, we have a bar here on the right side. If we turn the cube, we have a bar on the right side. And if we turn the cube, we have a bar on the right side. So that's how we can recognize this case. And another way to recognize it is from its predecessor, which we'll learn next here, and that is that we have the bars are all on the left side. So we'll go over that next, but anyhow, let's go back to this. So the algorithm for this at regular speed is, and now a bit slower, Okay, so for this fourth algorithm here, we have JB. And as I just mentioned, JB is very similar to JA, in that we have one face that is completely solved, and we have bars for the other pieces. And as I said before, all the bars are on the left side of each face this time. So unlike previously, when the bars were on the right side of the face, they are now on the left. So we can see there's a bar on the left side, another bar on the left side, and a third bar on the left side. And we have this solved face, which for our case it is red. So we hold the cube so that the solved face is facing us. And then we go ahead and do this algorithm. Here it is at regular speed. And a bit slower. Alright, so we have UA. And you might already know the algorithm for this case, but I'll just go over it anyway. And basically we have three edges that need to be swapped in a certain pattern. And we have one face that is completely solved, which for our case is orange. So when we're doing this algorithm, we want to remember that we want to hold the solved face in the back. And so we have the most important part of recognizing this pattern is to make sure we know which way the edges are being rotated. So this red needs to go here, the blue needs to go here, and the green needs to go here. So if we trace our finger, this is in a clockwise rotation. So we will do the UA permutation, which is the clockwise algorithm, as you might have heard it. And that algorithm is at regular speed. And a bit slower. Alright, so now we have UB, which is the exact opposite of UA. Again, we have one solved face, except this time, the corners, or the edges, excuse me, instead of being rotated in a clockwise rotation, this is a counterclockwise rotation. In other words, this red edge needs to go here, green needs to go here, and the blue needs to go back here. Trace our finger, once again, this is, instead of a clockwise rotation, it's counterclockwise. So we'll go ahead and do the counterclockwise algorithm this time, or UB. Here's the algorithm at regular speed. Now a bit slower. Okay, so for our last permutation here, we have the H permutation. And this one is really, extremely easy to recognize simply because all the edges are opposites of each other. So obviously the blue needs to go here, red needs to go here, and so forth. So in other words, the pieces that are opposite of each other need to switch. And it doesn't matter how you hold your cube when you do this algorithm, as long as yellow is your top face. So you can hold it on either red, blue, orange, or green, and the outcome will be the same. So here is the algorithm at regular speed. And now a bit slower. Alright, so thank you guys for watching this first part of my PLL Algorithms tutorial series. Now this is the third part of my series, I guess, of the overall series for cfoP. Now I hope you guys enjoyed this video, and if you found it helpful, then make sure to click that like button down below. And please subscribe to Cubing Outlet. TS and I would really appreciate it.